So in the last video we reviewed filters, and now we're going to look at comparisons and logical operators. Before we do that, I wanted to talk to you about Xquartz. So Xquartz was the library we needed to install to get the view to work. So we were trying to look at all of the data within the flights database right here. However, that wasn't available because we didn't have Xquartz. And the reason Xquartz didn't install automatically is because the version of my operating system wasn't up to date. I'm not going to update the operating system, so if you want to install Xquartz, make sure your operating system is up to date, and then you can install that and use the view function. Let's jump into comparisons. To use filtering effectively, you have to know how to select the observations that you want to use. R provides a standard suite of comparison functions, so we can do a greater than, a less than, a greater than or equal to, a less than or equal to, and then not equal and equals. When you're starting out with R, the easiest mistake to make is to use equals instead of the double equals. So right there, when testing for equality. When this happens, you'll get an informative error. So if we say month equals 1. So let's do filter flights month equals 1. And it tells us, did you mean to use the double equal sign? There's another common problem you might encounter when using the double equals, which is the floating point number. These results are definitely a little weird and surprising, so let's take a look at those. So if you take square root of 2, raise it to the second power, and we'll set, does that equal 2? The answer is false. That doesn't make sense. Because the square root, if you take the square root of anything and raise it to the second power, it should equal itself. So that should be true. Let's try another one. 1 divided by 49 times 49 equals 1. And that's also false. So the issue is that computers use finite precision arithmetic. They obviously can't store an infinite number of digits, right? So remember that every number you see is an approximation. Instead of relying on equals, use near. So instead of relying on the double equal sign, we'll use a near command. So let's say near square root of 2 raised to the 2, does that equal 2? And here you'll get true. So using near is a better way to apply the comparisons. It's an approximation. So instead of relying on the double equal sign, use the near command, near function. Next, we'll look at logical operators. Multiple arguments to filter and are combined with and. Every expression must be true in order for a row to be included in the output. For other types of combination, you'll need to use a Boolean operator yourself, which is and, is, and, or, and not. So we'll take a look at those. So and is the and command. The bar stands for the or. And then the not is the exclamation point. And we saw the that used earlier when we used the not equal to command. So let's take a look at how to use the or command. So we'll filter on flights that are either in November or December. So let's start with that. Flights month equals 1 or month equals 12. Flights, forgot the S. And you can see this returns 55,000 rows. The order of operation doesn't work like in English. You can't write flights equals 11 or 12. So you can't do that, right? Sorry, the last one we did January or December. This is not accurate. So this literally translates into find all flights that departed in November or December, but that's not. Instead, it finds all months that are equal to 11 or 12, an expression that evaluates to true. In a numeric context, like here, true becomes 1, so this finds all flights in January, not November or December. So this is pretty confusing. So if we hit enter, what this does, it returns all flights in January and not November or December. A useful shorthand for this problem is X in Y. This will select every row where X is one of the values in Y. We could use it to rewrite the preceding code. So let's use November, December, hold down Alt to get the caret, filter, flights, month, include 11 and 12. So what this does, it uses this same syntax, it gives the same functionality as up here. Imagine this month equals 11, and without having to rewrite month every time. So this is another easier shorthand way. And so we've simplified writing that code up here down to here, which makes it a little more compact and easier to read. Sometimes you can simplify complicated subsettings by remembering De Morgan's law. So De Morgan's law is that does not equal x and y is the same as does not equal x or does not equal y. So November and December, I misspelled that, and we'll talk about Morgan's law next. De Morgan's law. I can't spell to save my life. There we go. And so now if you call it November and December, it pulls in all the months for November and December again. So we were talking about De Morgan's law. So De Morgan's law says that not equals x and y is the same as not equals x or does not equal y, and does not equal x bar y, which is the same as does not equal x and does not equal y. So does not equal x and y is the same as, we'll say instead of saying equals x and y, and so we're going to do the two completely separate statements. Okay, so what this shows is that you can use these properties of De Morgan's law to apply it to our same scenario or same case. So if we wanted to find flights that weren't delayed on arrival or departure by more than 2 hours, you could use either of the following two filters. So let's take a look at these. So let's delete these. Actually, leave this up. It gives us an error. That's fine. We can use it. We can use those lines to reference it. So let's go filter flights does not equal arrive delay greater than 2 hours, and then or departure delay is greater than 2 hours. Close, close. And this will give us all the flights that were either arrived or delayed more than 2 hours. We got an extra parentheses here. We need that. So we're going to say does not equal. So there's that. departed delay. All right, that's 316,000 rows, and we can do the same filter by using De Morgan's law. Arrive delay less than or equal to 120, and departure delay is less than or equal to 120. So you can see these two filter comparisons are the same, return the same values, because instead of using an OR command here, we use the opposite, saying that flights are not equal to or less than or equal to 2 hours. Whenever you start using complicated multi-part expressions in the filter, consider making them explicit variables. That makes it much easier to check your work. You'll learn how to create new variables shortly. So, we'll definitely look at how to create new variables, so that instead of having these complicated filtering commands, we can just type in the variable, which makes it much easier to read and much easier to maintain your code. Lastly, let's talk about missing values. One important feature of R is that it can make comparisons tricky. It's missing values, or NAs, not availables. NA represents an unknown value, or missing values are contagious. Almost any operation that involves unknown values will also be unknown. So if we take NA greater than 5, we don't know. Is it greater than 5? We're not sure. Does 10 equal NA? Again, we're not sure. It's not true, it's not false. It's just it returns NA. So one of the most confusing things you can look at is, does NA equal NA? You'd think that'd be true, but we're not sure. It's not available. It's easiest to understand why this is true with a bit more context. So let's say X equals NA. All right. So we'll say we'll say that's Mary's age. X is Mary's age. Y is John's age, and we also don't know that. Are John and Mary the same age? So that gives you a little bit more context. Like, we don't know. I mean, if we don't know one person's age and we don't know the other person's age, we don't know their ages. If you want to determine if a value is missing, use is NA. So we can go is NA and then type in the variable in there, and this will return a true or false. So that says true because X is unknown, right? So that's one way to determine if a variable is not available. So we reviewed missing values, comparisons, and also how to do logical operators. De Morgan's law was very important. Definitely remember that going forward, and you'll be using that a lot in the rest of this course.